So in the previous two videos we've learned what valency in ions are, and in this video let us look at two examples of ions, and then let's see what happens when we get them close to each other. So here let us take the example of the classic example of sodium and chlorine. And so let us start with sodium. Here I have the sodium nucleus, which has 11 protons and 12 neutrons, and this is the first shell with 2 electrons, then the second shell with the remaining 1 2 3 4 5 6 7 8 9 10. So I have written 8 electrons here, 2 in there, total 10, and the remaining 11th electron just fits in there. 11 electrons, sodium. That is sodium. Now I'll just write the symbol there, Na. And now here on the other hand I draw the chlorine atom, and chlorine has an atomic number of 17, so it has 17 protons, and let me just check, chlorine has 18 neutrons, so 17 protons, 18 neutrons, fine enough. And because it is neutral, it should have 17 electrons also, so I'll put 2 there and I'll put 8 there, 1 2 3 4 5 6 7 8 10 there. Now I'm left with 7 electrons. I'll put them in the third shell, so I have 1 2 3 4 5 6 7, fine enough. So I have 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17. I hope that's correct. So I have 17 electrons of chlorine spread over the atom in that manner, and here I have sodium. So chlorine has the symbol Cl and sodium is Na. Now what does sodium want? If we focus on sodium, what does sodium want to achieve that great golden number of 8 electrons in its outermost shell? Well, obviously it wants to get rid of this one extra electron, because by doing that, if it gets rid of this extra electron, now if let's say someone gets rid of this electron, now it has only 1 2 3 4 5 6 7 8 electrons in its outermost shell, and it is happy. It has achieved the golden number of 8 electrons in its outermost shell, and it is following the octet rule. Now the problem with sodium is that obviously it first of all gains this positive 1 charge, because now it has 1 extra proton, because it has one because now it has 1 less electron. But yeah, it has achieved the stable configuration, and that's a good thing. But yeah, obviously it has this positive charge, and this extra electron that it has to do, it has to get rid of, right? It has to put that electron somewhere, right? It cannot just freely roam around. How would that really happen? And on the other hand, if you look at chlorine has 1 2 3 4 5 6 7 electrons in its outermost shell. Now what do you think chlorine should do to get 8 electrons in its outermost shell? Well, should it get rid of those 7 electrons? Well, no, because that's a very tedious task. It will have to get rid of 7 electrons, and by doing so it will gain a net positive charge of 7 of plus 7, and that will make it unstable. Instead, it can what it can do, it can simply ask someone for an electron, and if it fits that electron here, it would get 7 plus 1 8 electrons in its outermost shell, and it will be stable. So now chlorine is in search of 1 electron. Who should it ask? Well, obviously here sits the sodium atom. It should ask the sodium atom for that extra electron. Sodium here wants to get rid of this electron, and chlorine here wants an electron. So both of them are very happy to be friends and give this electron from sodium to chlorine. So sodium just tells chlorine, please take away my electron so that I can have these 8 electrons in my outermost shell, and I don't really want this extra electron. Chlorine on the other hand is very happy and says, yeah, I'll obviously take this electron, and this electron goes from there to here, and both sodium and chlorine are happy. Chlorine gains a negative 1 charge because it has an extra electron now, and now 1 2 3 4 5 6 7 8 electrons in the outermost shell. Both of them are perfectly happy, and now chlorine and sodium say, great, now we've done our deal. You've got the electron, and you've lost the electron. Both of us are happy with those 8 electrons in our outermost shell. Let us go away. But now the problem is sodium has a positive charge, chlorine has a negative charge. We know that positive and negative charges attract. So both of them try to leave, but both of them cannot leave because sodium is attracted to chlorine and chlorine is then attracted to sodium, and so both of them just stick together to each other, and both of them have to remain like that because they are oppositely charged and they attract each other and they have to remain together like that forever. So they are like a married couple now. They have to stay with each other in that manner. But yeah, they don't really mind being together because after all they've achieved this stable configuration, and so sodium is happy in stable form, chlorine is happy in stable form, and both of them live together happily ever. So yeah, that is how we take two atoms, form ions first of all. So we had two atoms, sodium atom and chlorine atom. We formed ions, Na+1 and Cl-1, and then those two ions came together to form, well, we can write them now together because they are a married couple now, NaCl, Na and Cl. And this thing, one thing is now a molecule. Now we'll come to that in more detail in the next module, but yeah, that is the basic way in which ions react together to form molecules. So it is kind of like the marriage of atoms together to form molecules or couples. No, they're molecules. That's it for this video.